Alright, imagine this. Using your smartphone and satellite data to help spot signs of colorectal cancer, all before you set foot in a clinic. Sounds like futuristic sci-fi, right? But it's actually happening, and I'm going to walk you through how and what you can do next if you want to get hands-on. So here's the quick start. First, grab the starter code from the Cancer Detection Suite repo. Or at least you would if it wasn't down at the moment. No worries, just keep checking or ask the owner for access. Once it's back up, it's as simple as cloning the repo and running a setup script. Next up, download the latest cancer detection models. They come as neat little TF Lite bundles, optimized for smartphones. You'll also want a satellite API key, which you can get for free using a single Python line. Just generate one with a quick call to UUID. That's your all-access pass to real-time environmental data from space. Now let's break down the workflow. The core of this system is a unified smartphone app. Here's what it does. You snap a photo of a nanoenzyme test strip, which is designed to detect D-lactic acid, a key biomarker for colorectal cancer. The app analyzes the image, grabs your location, calls the satellite API, and pulls in regional water quality data, NDVI, and land surface temperature. All of this gets crunched by a machine learning model right on your phone, and you get a risk score instantly. If the risk is high, say, above 0.7, the system can even dispatch a UAV to collect water samples for further testing, right where you are. If it's moderate, it suggests monthly monitoring, and if it's low, you're good for routine screening. All this is visualized in a super clear dashboard, and everything syncs to the cloud for secure backup and remote viewing. The tech stack? It's pretty slick. Camrax and Kotlin for the Android app, TensorFlow Lite for efficient on-device ML, Sentinel Hub API for satellite data, Mavlink and ROS2 for UAVs, and AWS Lambda keeping everything ticking in the background. You can whip up a prototype in under a week with this cheat sheet. And here's my pro tip: start with colorectal cancer. The D-lactic acid signal is strongest, satellite water quality data is spot on, and the UAV sampling is straightforward. Rivers are ideal test beds. Once you've nailed that, you can expand to other cancers and biomarkers. So what are the next steps? Set up your dev environment, grab the models and satellite key, wire up the image analysis and ML prediction, and link in the Sentinel Hub API for live environmental info. Configure UAV logic for urgent cases, plug in the cloud backend, and you're off. This is cutting-edge, real-world medical tech, and it's open for anyone to try. If you're a developer, a medtech enthusiast, or just curious about where science is heading, now's your moment. Dive in, build, and help push the boundaries of cancer detection, from the ground to space and back again. Thanks for watching. And remember, always seek clinical advice for any medical concern. Stay curious.